This model shows a pneumatic disc brake system with compressed air supply and distribution to the individual compressed air tanks. The compressed air supply is provided by a compressor element. The compressed air leaving the compressor's discharge nozzle has an elevated temperature, which is cooled down by means of a cooling line. The piping element used includes the possibility of transferring the heat to the environment. The air filter element, located in connection with the cooling line, is considered in the model by means of a throttle and two volumes. The compressed air is distributed to the individual circuits and vessels via the 4-circuit protection valve. This brake system consists of 4 disc brake elements, that is, 2 per axle, which are operated by 2 brake chambers or membrane cylinders on the front axle and by 2 spring brake cylinders on the rear axle. The service brake can be actuated by varying the signal input at the foot brake valve. The front brake cylinders are supplied with compressed air directly via the foot brake valve. The pressure reduction in the brake cylinders of the front axle is accelerated using a quick release valve. The brake circuit of the rear axle is equipped with a relay valve near the rear brake cylinders. This valve is actuated via a control line connected to the foot brake valve. In addition to the function of the service brake, the spring brake cylinders of the rear axle also provide the function of the parking brake. To release the parking brake, the spring-loaded chamber of the cylinder is pressurized with compressed air via the parking brake valve. In the model, a proportional relay valve is used to represent the functionality of the parking brake control valve. The simulation results show the system behavior of a full-stroke service brake application and release. As a result, the response time of each individual brake cylinder can be analyzed. This model can also be used to perform an 8+1 repeated full-stroke service brake application to evaluate the fulfillment of the requirements of the ECE-R13 Regulations regarding the capacity of the stored energy, in this case, the compressed air in the reservoirs. For this purpose, the compressor is switched off in the model. The relevant results are the pressure levels in the compressed air tanks, which, after 8 full actuations, must not fall below the pressure necessary to achieve the prescribed secondary braking performance. SimulationX can be used to accelerate the design of your pneumatic systems and ensure they fulfill requirements and regulations. For more information, see our website linked in the description.